So my name is Naka Mutedi, Computer Science here at Makere University, and I'm going to take you through our implementation of our machine learning project. And the topic, multi-strategy personal legislation for fraudulent gas and power consumption detection. So first of all, we import the necessary libraries. And in our case, we imported libraries like pandas, NumPy. We use the skitlearn to import the different classifiers of the models we're working with. And after we import the necessary libraries, we go on to load our data sets. So we had already uploaded the data set to Kaggle. So we use the Kaggle path to access our data sets. So then we can be able to see the features and the content in the data that we have. So our data set had two data frames, the client and waste data frames. So after that, we went on and merged the data frames to have one, because these two data sets had a common column, which was the client ID. So we merged the data frame according to the client ID. So here we're able to display the merged data frame. So next we went on and did converting of categorical columns. Remember, we're working with different models. So some models cannot directly access the category data, so we need to convert it to strings. So that is what we did. And then next we applied some label encoding. So we applied label encoding with the merged data frame. So because these so that we can be able to use these categorical variables without inheriting or ordering, like inherit ordering. So we apply the label encoding and we use these lines of code to transform the merged data frame. So then we filter out the numerical columns, after which we calculate the correlation coefficient. This correlation coefficient helps us to get to know the relationship between the different columns that we have in our data sets. And then after that, we do some handling of missing values, but in our data set, we realized that we didn't have missing values. So we convert the categorical columns into numerical using the label encoder, which we initially imported earlier on. So after that, we do some correlation for feature selection. We do some Pearson correlation for the feature selection. So we select the best features for our models. So after that, we did some information gain. So we did some information gain and calculated the information gain using these lines of code. So why we did that is that, excuse me, why we did that was that some metrics in machine learning, that it's the statistics measure how features contribute. So this information gain helps us to know how much do these features that we have in our data set contribute. So then we also went on to normalize the data set. So we normalize the data set using a standard scaler. So when working with some models, we need to scale features to bring them to a similar range. So that is why we did the scaling. So that will prevent the values from dominating, some large values from dominating the smaller values. So we only keep the important features, and we could finally print the final data frame that we have by this time. So we went on and used oversampling and undersampling techniques. And for undersampling, we used near miss, and for oversampling, we used SMOD to be able to handle the imbalanceness of the data set that we are working with. So we went on and did a stratified operation onto the features that we have. So we did the stratification because we wanted to ensure that the data set has the same portion of classes as the original one, like the data set we're working with currently has the same portion of the classes in like the original data set. So after that, we do the splitting. So after stratifying, we do the splitting. So we split the data frame into the X train and Y train, even the Y test. So we get the train data and also the test data. And in this case, we did a split of 80 to 20, that is train and test. So after that, we went on and trained our random forest model. So currently, this means that we're able to train it using the data that the clean data that we've recently cleaned or featured well, so that this random forest model is able to learn. So, and we went on and got the prediction of this using the test data. So we trained using the trained data, and then we get the prediction using the test data, and then we go on to print the evaluation of the different metrics that we use to. So we use the accuracy, the confusion matrix, and also the precision. So after that, we went on and did the confusion matrix for that random forest and be able to plot a heat map. So after that, we went on and tuned the parameters of this data frame, of this model that we worked with, the random forest classifier. So we went on and tuned it well so that we could get the right labels to feed to our student model. So then we go on and train the model on feeding on the X train and the Y train, and then we go ahead and do the prediction. So we evaluate this model accordingly. So after evaluating the model, we go on and save it to our model file, and we save it as a pico file. So after that, we do some feature importance, because there are some features that really are more important than the others. So we go on and do some feature importance, and in this case, we did it, and we're able to print the feature ranking of the different features that we have. So we did hyperparameter tuning to this model that we had trained to be able to select the model. And then we were able to visualize this in using the parameters. So we're able to get the best parameters and the best accuracy, so that we can be able to choose which model to pick to be a student. So we go on to test the best parameters, to train the model with the best parameters. So after training it, we do its prediction and then also save the model as a pico file. So after saving that, so we do some feature engineering to that model, then drop some low features with low importance, and create a preprocessing pipeline. So we also create a model pipeline for it, and then we use the more focused grid for the feature importance, those features that are important. So we randomize the search from a full grid, a more efficient full grid search, and then after doing all that, now we're ready to train our model, which is a random forest in this case. And it was the best performing model with the best parameters and the best accuracy. So we will go on to evaluate using the test data. We evaluate this model, and then we print out its accuracy or its metrics of measure, of performance measure, and then we also save it in the in the file. So after this, we went on and created an API, and then created an app for this model so that we are able to deploy a model. So my friend will take you more about the deployment of the model and how we're able to work with it, with the user interface we're able to create for it. Thank you.
Hello, my name is Namata Haula. I'm going to stop from where my friend, I'm going to start from where my friend stopped and take you through that deployment. So we used Flask for deployment, and uh, I went to the root folder where the project is and created this app.py file. And so inside this app.py file is where I imported everything else that I was going to use. I had already pre-installed this in the Anaconda command prompt or in the Anaconda shell. I'm going to show you that later on. So inside this app.py file, I load the model and I provide a link to the landing page so that once our model is deployed either locally or on the cloud, you have a link you can, and when you tap the link, there's a page where you go to that is our landing page or a home page. So I had to create that, which is here the index.html file, and here below is the logic, the code that helps you to like make a prediction, like, and once you've entered like the features as the model expects them. Once you enter the features here, the model is able to interpret and make a prediction. So this is what the index.html file looks like. So it is just a simple form, as I'm going to show you later on, where you enter the features. Here it prompts you to enter the features, which are comma separated. And after entering the features, there's a predict button that once you press it, the model is able to make a prediction. So this is just a JavaScript that gives the button what? Action. And basically that's it. And also once before we deploy, we were required to create this requirements.txt files, which has all the necessary dependencies and the libraries that are necessary for you to like deploy the model, and also required to create this procfil file. This proc file that just has a start command to initialize the Unicorn app. And then so just to share with you what the so we first deployed locally. We're using like the Anaconda. This is what the Anaconda command prompt or shell looks like. So inside here, you enter the features. You first install all the features you're going to use, and everything you're going to use, the dependencies and everything that is required for you to deploy the model. Once that is installed, we prompt it to start the app. Like we navigate the products to the project folder and start this Python app.py file, and then it gives you this link which you follow to see what your locally hosted app looks like. And then you make the necessary debugging, and so that if the local app is set, you can continue to deploy on a cloud platform. So I'm going to show you that later. So once this was set up and we saw what the local server was looking like, we made the necessary debugging. And after that, we were able to deploy on Render. So this is just basically what the Anaconda command prompt looks like. And I just wanted to share and show you. So so after that, so after that, when the local app was set up and it was fine, we deployed our model on Render. So for you to be able to deploy on Render, the project has to be hosted on a version control system like either Lab, GitLab, or GitHub. So we pushed everything. We pushed our project. We first of all pushed it to GitHub. This is everything as I was showing you. This is what it looked as this is what it was looking like in VS Code. So we pushed it to GitHub. Then after pushing it to GitHub, we had already initialized a repo in the Anaconda shell. So after pushing it to GitHub, we connected the repo to Render, and we deployed the latest commit, which was our model. And here it was showing us our service was live. And once the service is live, they give you you are assigned a link. Once when you follow this link, we when you follow the link, we see the hosted version of the model, and we see if the model is working as we expect it to. And this is taking long, but I had already like run my server before. This is the local server. It was able to make the prediction. You want to enter the features, comma separated, and you click predict. It is able to make a prediction. This is taking long, but I think I was, yeah. So this is what the hosted model looks like. And once you click predict, it brings a 0. I wanted to start and show, but this is taking abnormally long. But so once you enter in the features as expected, as you start like the district, the counter type, counter information, counter status, and click on predict, our model returns a prediction. So this is how our model works. Thank you so much. We shall improve on the interfaces and make improvements later on. Thank you so much.